following definite integral. So we got definite integral from 0 through pi over 6 of this fraction. So we don't have fraction rule for integral. So first off, we need to get rid of this fraction. One way to get rid of a fraction is just splitting into two fractions, like root 3 sine theta over secant square theta plus the whole thing divided by secant square theta. But I don't see any cancellations if I split into two fractions. But what I see on the top here is root 3 sine theta and root 3 sine theta. So I can factor these two terms, this on the top. So let me do that, okay? So this is 0 through pi over 6 on the top, because they are same. I can factor root 3 sine theta. That leaves everything out, so 1 plus, this is out, so times tangent square theta, so that's tangent square theta, all over, we still have secant square theta on the bottom, d theta. Okay, still there is not much of improvement, but if you look at closely inside this parenthesis, 1 plus tangent square theta, so there is a Pythagorean identity. 1 plus tangent square theta is in fact secant square theta. So this is in fact secant square theta. So that makes 0 through pi over 6, 0 to pi over 6, root 3 sine theta. So I don't have to write parentheses, so I'm dropping that, times 1 plus tangent square is secant square, all over, I got secant square theta on the bottom, d theta. Now this is times, look at that, secant square, we can cancel. Then that leaves 0 to pi over 6 of simply root 3 sine theta. Okay, now this root 3 can be pulled to the front, so I'm going to write here root 3 outside. Then I can simply take antiderivative of sine theta. Antiderivative of sine theta is a times negative cosine theta. Okay, antiderivative of sine theta is just negative cosine theta. Now I pull this out, so I don't have to worry about this. So 0 through pi over 6. And in fact, this negative means negative 1. I can pull all the way outside as well. I just need to evaluate this function from 0 through pi over 6. Okay, this negative 1, in fact, I can pull all the way to the front. So negative 3, root 3. Now cosine theta is pi over 6, so upper limit. So cosine pi over 6, upper limit, minus, from fundamental theorem of calculus, cosine lower limit 0. Okay, that is now negative root 3. What is this? Cosine pi over 6, cosine 30 degrees. Okay, now you need to look at the unit circle. Cosine pi over 6 is in fact cosine 30, that's root 3 over 2, minus cosine 0, that's 1. So you may leave here, the best you can do is just distribute. So this is negative root 3 times root 3 over 2. So root 3 times root 3, that's on the top, root 9, which is 3. So this is 3 over 2 minus, and this one minus, and this negative, and minus, plus root 3 times 1 is root 3. Okay, final. Negative 3 over half, 3 halves, negative 3 halves plus root 3. Now the next question is here, 5 minus 5 sine square theta over cosine 4 theta. Again, we got a fraction. Maybe we can, to get rid of this fraction, we can split into two fractions, 5 over cosine 4th minus 5 sine square over cosine 4th. Again, I don't see any cancellation, but there is a hint on the top. like the previous question, 5, 5, we can factor 5 out on the top, and let's see. 0 through pi over 4. When we factor 5 out, that leaves 1 minus sine square theta all over cosine fourth theta d theta. Okay, so that is now 0 to pi over 4. Okay, 1 minus sine square. There is a Pythagorean identity. Sine square plus cosine square is 1. From this we can make another identity. If we subtract sine square from both sides, we get cosine square equals 1 minus sine square. So 1 minus sine square is in fact cosine square. And if we had 1 minus cosine square, that would have been sine square. But here 1 minus sine square is cosine square. So this 5, and in fact let me put 5 all the way outside. 1 minus sine square is cosine square all over cosine 4 theta d theta. Next is a 5 cosine square over cosine fourth. 2 copies, 4 copies. We can cancel 2 copies from top and bottom, and 2 copies left from the bottom. So this is 0 through pi over 4 cosine square cancel. So 1 over cosine square d theta. We still have a fraction. Let's see. 5, 0 through pi over 4, 1 over cosine. That is reciprocal of cosine. That's secant. So 1 over cosine is in fact secant. And we got a square. Secant square theta d theta. Now this is nice because we know antiderivative of secant square tangent theta. So there's 5 outside. Antiderivative of secant square is tangent theta. And we evaluate from 0 through pi over 4. Now we just plug in upper limit for theta and minus lower limit 0 for theta. So tangent pi over 4. Tangent pi over 4. So need to write the value of tangent pi over 4, which is 1, 1045, minus lower limit tangent 0. That's 0. And 1 minus 0 is 1 times 5 is 5. So 5, that's final.